The library as we know it has historically been a repository for physical materials, primarily books. With the advent of the internet and the increasing amount of digitally born information, including online magazine articles and e-books, libraries are looking toward the future and how the physical library space might fit in. Changing technologies including electronic databases, OPACs, heating and cooling systems, and lighting design must be considered when renovating, reusing, or reinventing existing brick-and-mortar library buildings. Library facilities must expand structurally in order to incorporate the hardware that comes with information technology. The estimated shelf life of a brick-and-mortar library is around 20 to 25 years. Rapidly changing technology largely contributes to this finite lifespan. As years pass and new systems are introduced, library infrastructural and mechanical systems become out of date or even obsolete. In order to keep pace, libraries are often torn down and rebuilt from the ground up. However, renovations and additions to existing structures can also be utilized as tools to integrate new technological systems. Many older buildings allow for flexible use even if their original design could not have anticipated 21st century technology. In the process of designing a renovation, addition, or even when replacing furniture, creative use and informed foresight can allow for an innovative and efficient reinvention of the space. The use of an outside expert as a consultant on the project can help define, through subjective analysis, what changes or additions may be necessary. This will decrease vested interest and help keep focus on a clear strategy when moving into the design process. A well-reasoned and researched design can accommodate future expansion and reasonably extend shelf life. As library buildings age, some problems that may arise include structural or seismic issues, out-of-date or obsolete equipment, wiring and lighting, inefficient furniture that is not suited to new computer hardware, inefficient construction materials, mechanical or control rooms that are not large enough to accommodate updates to electrical or IT infrastructures, and inefficient or ineffectual lighting that may have been modified or obstructed over the years. With new technology comes new hardware. Most libraries in the United States have migrated their catalogs from paper-based card catalogs to online public access catalogs. OPACs can allow for more informationally rich surrogates since computer-based records do not demand as much physical space. In spite of this benefit, OPACs do require dedicated computers that are powerful enough to effectively perform advanced database searches. In turn, because of increased querying as well as greater demand for free internet access, libraries must equip themselves with more capable servers and networking solutions. Administrative tasks are also becoming automated. Circulation has become self-serve, and return books can now be sorted robotically. Linked to patron circulation records, these mechanisms also require control by library servers and integration into the library's network. In order to accommodate the hardware necessary, libraries must build mechanical rooms that can house server and control hardware that meet current demand but also can anticipate expansion for future data requirements. In order to integrate new hardware into the library, data and electrical wiring that may not have previously existed within the building may need to be installed. Often, electrical systems must be upgraded to meet the heightened demand that comes with running more computer terminals and servers. Internet networks must be wired in part, even if they provide wireless service. Adding wires to pre-internet structures can be problematic, though retrofitting solutions do exist. Wiring can be installed under the library's flooring, accessed through panels if future updating or rewiring is necessary. Similarly, wiring can run overhead, hidden by a lattice of ceiling tiles, or even left exposed. Lights can also be integrated into a drop ceiling, though more impermanent movable fixtures are preferred. Fixtures attached and easily detached from study carrels or the tops of stacks are flexible if in the future the library interior is rearranged. Light sensors can detect changes in light levels and adjust the light accordingly as natural light waxes and wanes. Keeping light levels consistent and at the lowest level necessary for each respective library task will reduce glare and save energy, especially when the library is closed at night. These sensors can be used to control both interior and exterior building lights. Because libraries can now offer wireless internet access, stationary internet workstations are no longer as necessary. Many libraries have chosen to reformat these areas, opting for open, flexible plans. These spaces can be used for reading, computing, socializing, and can easily be transformed into temporary event spaces. Instead of using furniture equipped with data ports that can only accommodate a certain number of patrons, a wireless network now offers libraries the flexibility to expand patron access anywhere in the building. By placing comfortable seating throughout the library, rather than in a defined space, the library can utilize more natural light and both save energy and create a pleasant reading and working environment. Heating and cooling is essential to creating a comfortable and inviting environment for library patrons and staff, not to mention crucially important to protecting library collections. By replacing old windows and roofing materials that may have leaked air with their energy-efficient counterparts, a more consistent interior temperature can be better maintained. This will also decrease energy usage, allowing resources to be diverted to other library services and decrease sudden changes in temperature that may damage fragile collections. When entertaining structural or infrastructural retrofits, not all libraries will require the same services, though the overall sustainability of design is an important factor to consider. The initial costs associated with sustainable solutions can be high, but can be offset as years pass. With fewer or more easily replaceable components and off-grid solar-generated power, buildings with sustainable designs face fewer maintenance issues as they mature and potentially produce less waste. The U.S. Green Building Council, which bestows LEED certification, has begun working with the National Trust for Historic Preservation to incorporate the preservation of existing buildings as part of the certification process. Historic or older buildings that incorporate green building strategies can also factor the reuse of their existing structure as a means towards certification. Many library buildings undergoing renovations have also begun to source salvaged materials from demolished buildings, thus reusing materials that would otherwise go to waste. In all cases, it can be concluded that the more flexible or adaptable designs are, the more easily new technology can be integrated. By proxy, the library can then perform more effectively, both operationally and as a public service provider.